Okay, so first, briefly, for those of you who missed the previous lecture, um, or who just want to recall, so last Saturday, we discussed that there are different ways to uh, read and understand brain activity. So, for example, there are electroencephalograms, also known as EEGs, like this one. This is the Neurosity Crown that we will be discussing today in more detail. There are also MRIs that clinics use, which measure the blood flowing in your brain based on which area of your brain you're using currently. Like for visual tasks, we use the back of our head. For auditory tasks, we use these places. For movement, we use this area, and so on. There are ways to open up your skull and put electrodes inside your brain, and there are ways to just put a headset on and take it off. That's invasive versus non-invasive. There's also different kinds of methods that predict your brain activity from your eye movement, for example. In fact, for example, in sleep, that's what REM sleep and non-REM sleep means. So REM sleep means rapid eye movement. So basically, if your eyes move a lot, that probably means you're dreaming in REM sleep. So we have different ways of measuring what is going on inside our brains and even some ways to affect that. So for example, there was transcranial direct current stimulation, which basically applies some electrical stimulation to your brain and it can make you more focused or it can help you learn faster. It's also kind of in electroshock therapy, although that's um, less precise, but this is more precise. And so basically, there are many different ways to read or write into the brain. And what this allows for is, for example, for educational purposes, that's an easy one. But also, you could make them some kind of apps with programming that, for instance, let you study better. So let's say you want to keep studying, but if your focus drifts, you want to either automatic music to turn up, or maybe some kind of warning to appear on your screen, like go take a walk and then come back, or something like that. So basically, it allows you to take a higher level of control over your life and over your mind. Also, it through the phenomenon of neurofeedback, which we discussed last week a little bit, basically can allow you to learn how to increase or decrease your level of focus and calmness. And in some cases, also, it can help people with overcoming pain or PTSD or addictions, even. This is still a new field emerging just now. And I don't intend to focus on the science of it today as much. Today, I want to focus on the engineering of it. And what I mean is how we can use our Python programming that we learned so far to actually do something with our brain. So for today, I'm going to be discussing the Neurosity Crown device, this one. And this device is an EEG, as I mentioned, which means that it measures the electrical activity in your brain. So you can see here it has these electrode groups. So each of these would measure electrical voltage changes in my brain. And so as we recall from before, the way our brain works is that neurons talk to each other in synapses. And in order for neurons to talk to each other, they must build up a lot of voltage and then they must spike, which means that this voltage must discharge, go away. And these changes in voltage can be detected by devices when they're concentrated enough. So this phenomenon is then used to basically figure out, is a person right now calm, or is he anxious? Is he focused? Or is she thinking about moving her arm or her leg or something like that? Is she angry right now? Is she lying right now? Is he depressed? Is he in pain? And can we do something about it and such? So the abilities that we will discuss today is that we will measure uh, just basically raw brain waves at first, just to see what it looks like inside my head. It won't really mean much, but we can take a look at it. Then we will see that we can measure the percentage of how calm I am, how focused I am. We'll also discuss how this actually works, but for now we'll just use it. And then another interesting thing this thing has is that it can measure motor commands. So motor commands are anytime I move my body or even think about moving my body. So for example, when I think to curve my finger, there's a specific region in my brain's motor cortex. So this is the motor cortex around here. And a specific region will light up for each specific movement that I do or even think about doing. And so this device can pick up on that. And what it can do is, for example, with programming, we can set it such that, let's say, every time I think about moving my right index finger, I don't know, send me some text or take a screenshot of a laptop or just do something. Maybe just print it on the screen that, hey, you're thinking of this. And we can then later use it maybe for games, maybe for remotely controlling like a robot or a car or something. The applications of this are quite limitless, but for now, let's just focus on what it is that we can do. All right. If you get any questions at all, feel free to interrupt me either in a chat or just in conversation. That's all good. And right now, I want to discuss first, before we get into the code, just a brief review of how this works and then how to wire it up. So here's what I'm going to do. I'm going to go over yesterday's slides just one more time. 1 second. All right.
Hello.
Hello. We are starting the lecture right now. We are reviewing what we discussed last week, and then we'll get into this device and how to use it. Also, yeah, we're recording this whole thing, so feel free to rewatch it on YouTube or go to a specific section or whatever, no problem. All right, so what we discussed last week was that we have brain-computer interfaces. They work in a couple of different ways. We don't need to get into every one of them right now, but basically pretty much all of them either measure the electrical activity of our brain from neurons talking to each other, or some of them measure blood flow, because like depending on which brain area we use, that area will now need more air, more oxygen, so more blood needs to flow to it, and that's how MEGs and MRIs work, for example, in clinics. So there's different levels of invasiveness, so that is how deeply into the brain we have to go to record something. So for example, EEG suggests on the surface of our head, like there's no surgery, I can put it on and take it off whenever I want. There's also a method called ECOG, as you can see on the screen, which is just you take off the skull and then you put it on the surface of your brain. And then there's also electrode arrays and single cell recordings that go deep inside your brain. For those are deep brain surgeries that, for example, Neuralink uses, which gives you a higher level of signal, since right now, whatever signal this will pick up on will be the signal that started in my brain, but then has to go through the skull. So a lot of it was lost. So basically, you will get a lot more resolution if you go deeper into your brain, but it's less comfortable. You have to do surgery, you need permissions legally, there's also risks and so on. So whatever you can do without surgery is better. So this one is completely non-invasive, which just means that, yeah, put it on, take it off, no risk at all. So that's what we'll be using today. Right, so different ways. Neuralink uses a completely invasive method, which means that they go deep inside your brain. And currently what the Neuralink chip does is that a paralyzed person is able to use a computer or a phone, like text and even play video games, just by thinking about it. So the way they do it is by mapping the motor cortex, which actually we will also do in today's lecture, although not to that level, but a little bit. So what that means again is that every time you think about moving your hand, and I mean, paralyzed people can't move their hands, but they can still think about moving their hands. So this device would detect it if a person is thinking about moving his right hand, for example, and maybe they have it mapped so that if I think about my index finger, type L, if I think about, I don't know, my left hand, type R, and things like that, or maybe just go left or right and pick the button. I'm not completely sure which method they use, but yeah, they can quickly type and they can even play video games. So this is just a Neuralink chip structure, and this is why it's uncomfortable thing to do generally, because you have to put all of this into your body. It has to be non-toxic to your body. There must be no immune rejection and all the other biological problems. And basically non-invasive devices like this completely avoid that because, I mean, you're not putting it inside your body, so it's just a headphone you can put on and take off. All right, so again, non-invasive ones are ones that don't go into your brain, such as EEG and MEG. Invasive ones go maybe a little bit on your brain, like on the surface of it, or deep into your brain. The deeper they go, the higher resolution they get, which is good for data, but it's also more risk of what medical damage you could do, how much legal permissions you need, how much more expensive and difficult it is, and so on. So this is, for example, ECOG, electrocorticography, which is basically same as EEG, but it bypasses the skull because they open up your skull and then they put the device in there, like on the surface of your brain. Like, in fact, the way our brain works is that the skull is a bone, obviously, that protects us from the outside world. But then between the skull and the brain, there's also this 3 layers of tissue that protect our brain, basically cushion us so that when we hit our head on something, we don't get as much brain damage. So these three are called meninges, and they are the dura mater, the arachnoid mater, and the pia mater. And the ECOGs basically go generally between dura mater and arachnoid mater. This doesn't matter right now, it's just an overview. So there's a synchron brain device. There's also fMRI, which detects blood flow in your brain. And then there's also some ultrasound devices recently, which can both read your brain activity and write to it, even though it's not invasive. It's just a headphone you put on and take off, and which in a few years might cure chronic illnesses, depressions, addictions, anxiety, and a lot of other problems. So it's one of the more interesting ones as well, I would say. But it's not quite consumer ready yet, so like you can't just buy it and use it. But yeah, they can scan your brain activities and such. Nudge is the company making those ultrasound devices. This is what it looks like right now, but they want it to look like just headphones like this in 5 years. Well, we'll see how it goes. But today we'll be talking about EEGs, which is electroencephalograms, which basically means that they measure electrical activity of our brain and from that figure out, oh, he's using this side of the brain, or he's using this much of this side, or this frequency, these brain waves. Therefore, he must be focused or calm or something. And yeah, again, the way this works is that our neurons are electrically charged a lot when they communicate, and we detect that. So basically, how this works. So each of these areas, I mean, when I put this on my head, I don't need this to be plugged actually. Yeah, so, sorry, like this. When I put this device on my head, you can see that each of these would go on different brain areas. And here's how we generally figure out which area it is. So if any of these were right on the center line, they would be Z. So we say, for example, PZ for parietal lobe center, CZ for the central area center, FZ for frontal lobe center, and so on. So as you recall, frontal lobe, parietal lobe, occipital lobe, temporal lobe. And so also we say that right sides are even numbers and left sides are odd numbers for this. So for example, if I recall, these ones are frontal 4 and frontal 3, I think. And these are frontal central 3 and 2, and so on, or like 2 and 1. And basically that's how we number them. So what we know which electrodes we are looking at in our code. We'll get to that in a moment, but basically, yeah, each of these are a unique location on our brain. And from there, we can tell that, oh, this must be looking at my hand activity, or this must be looking at my visual activities. Like these ones go to the back of your head. So they are more about your occipital lobe, which is where your visual cortex rests. So these two would be for anytime you imagine a visual. But for any motions you think about or do, it would mostly be this frontal ones, since they touch the motor cortex more. So we'll get more into that in a moment. But yeah, that's a rough idea. And so this is the device we're talking about. It's the Neurosity Crown. And basically the reason why I chose this device is because it's something that you can just buy directly. It costs $1,500, so it's not that cheap. There are cheaper variants like the Muse and such, but this one is able to do more things, basically. So I want to discuss with this for now, and because I have it at hand. So it can do some cool commands that we'll get into, but basically read your focus or calmness level, read what motion you're about to do, or read raw brainwave data if you want to figure out how to correlate it to something yourself. Like for instance, maybe you think that with enough examples, you can train an AI to recognize, oh, this is what it looks like when I think about elephants, or when I think about giraffes, or when I think about lying, or some specific thing. Because, like, if you think about it, in principle, every time we think about something, it's a distinct, unique neural activation that corresponds to that idea. And so if we were to do it enough times, like think about elephants, now don't. Now think about now don't, and just keep measuring what our brain looks like. You could train an AI to figure out, oh, if your brain looks like this, you're probably thinking about elephants. So that's why you could stream raw brainwave data to then do some AI stuff like that. We're not going to do that today, I just wanted to mention it. But now let's just briefly review brainwaves as well, because this is for focus and calmness levels. So basically, what does a brainwave mean? Our neurons talk to each other, and they do this by spiking, so which means that they send signals to each other, and they do this at some set speeds. So on average, the neurons talk to each other at about 1 hertz. Hertz just means something per second. So 1 hertz just means one signal per second. Each neuron roughly speaks about 1 hertz speed, but our important brain areas are generally more active than that. So in everyday life, we are mostly in beta waves or alpha waves, mostly in beta waves. So like right now when I'm doing this lecture, my brain will be in beta waves, which just means that most of my neurons here are firing at about 12 to 30 hertz, so 12 to 30 times per second. If I'm in deep sleep or a coma, I will be in delta waves, which is from 0.5 to 4 hertz. If I'm dreaming or in trance or just very relaxed, I will be in theta waves from 4 to 8 hertz. If I'm just relaxed or meditating or just very distracted, I will be in alpha waves from 8 to 12 hertz. If I'm somewhat focused and alert and thinking, I will be in beta waves, which is 12 to 30 hertz. And if I'm super focused, like if I'm playing a very intense game of chess or just something that requires a very strong amount of focus, we will be in gamma waves, which is from 30 to 100 hertz. It's possible to go above that, but it's extremely rare. So these are the main things. And basically, for example, you can tell how focused someone is based on how much beta waves they have in their brain versus how much alpha waves they have in their brain, for example. Because a very distracted person would have, let's say, mostly alpha waves. A very focused person would have mostly beta or gamma waves. So basically, you can just, if you were to just measure beta wave amount and measure alpha wave amount, then just divide them by each other, you would get your focus level. So that's roughly how the Neurosity Crown device figures out how focused you are. Yeah, so your low theta to beta ratio means high focus. That's pretty much it. And also the phenomenon of neurofeedback, which we can't really demonstrate here. It's a little bit complicated, but the basic idea is that we can show you something on a screen that you will think about, and then your thinking pattern will change what you see on the screen. And this will actually allow you to control your thinking. And basically what this means is that, for example, let's say we make a game in which the more focused you are, the taller a tree grows. I actually have a YouTube video about this. I recommend you check it out. So basically, if you make a game where as long as you stay focused, the tree keeps growing, but if you stop being focused, the tree starts to shrink. Even though you generally may not be able to directly control your focus level, just by taking a look at that tree and figuring out, oh, now I'm growing the tree, now I'm shrinking the tree, just focus on the tree itself, you basically learned how to control your own focus and how to set your focus up or down. And so that's a phenomenon of neurofeedback, which is that when you can correlate your brain activity to something you see or hear on the screen, it allows you to control it. And this can basically help you to take control over your addictions or your anxieties or just any kind of problems with your cognitive abilities. And yeah, this brain stimulation is something that a lot of militaries and other agencies are focusing on to see if they can make you learn faster. So the goal here would be that eventually maybe we can just get a 1,000-page book and just download it to our brains. Or maybe if we could just read one person's brain activity, let's say this person is a physicist, then we take his physics knowledge and give it to another person, or maybe even a karate knowledge and give it to another person. And actually, that has already worked a little bit in mice. So they had two mice in two different cities. One mouse was trained to know that every time it pressed a specific button, it would get the food. The other mouse didn't know this, but they connected the brains of the two mice, and then the other mouse instantly just knew that, oh, I had to push this button to get the food. It is believed that this was easier to do because it was a simpler idea to send, but in principle, eventually we should be able to just send entire ideas, or knowledge, or even memories to each other. So we might have like people who, let's say, open source their memories, so you can basically experience what he was experiencing yesterday and things like that. Uh, our technology is obviously not there yet today, but what we're learning now is the foundation to allowing such things. So foundation to higher levels of self-control, meditation at will, or even deep trance at will, or learning faster, learning like a million times faster. Like imagine right now, an average book would take, let's say, a week or two to read. Imagine if you could read that book in a minute. Yeah, that will probably eventually be a thing in a few decades. And so we're basically laying out the foundations for those. But I mean, to get back to reality, present reality, uh, mostly today the brain devices are used so that either paralyzed people can communicate better, or people who have either depression or some kind of attention issues or ADHDs or addictions or chronic pains, they can use the neurofeedback phenomenon to basically get more self-control and be better, feel better. All right, with that out of the way, let's now get into this device a little bit more, and then we'll focus on actually writing the code for it. Okay, so far, do you have any questions?
No.
All right, good. So, the Neurosity device. Let's start with the website that they have. So this is consoleneurosity.co. I mean, their website for outsiders, let's say, is neurosity.com. Just a moment. So let it load. Okay, it's taking a moment. But in the meantime, this is a website they let you use to connect to your device. So this is consoleneurosity.co. I'm looking at the settings right now. So this is the name of my device. And these are the channel names. So these are called channels. There are 8 of them on this device, which means that I'm measuring 8 different places on my brain. I'm not measuring my entire brain, obviously, because there's gaps between them, like I'm not measuring anything here and so on, but this is still enough for our purposes. So what do we see here? This is the name of my device. These are the names of locations on my head which I'm measuring, and here's how it reads. So C stands for central, F is for frontal, so this is frontal, this is just central generally. P is for parietal, which is this brain area. O is for occipital, so the back of our head. And yeah, basically CP means central parietal, so about this area. C just means central. F is frontal. PO means parietal occipital, so between parietal and occipital, like somewhere here. And these numbers, basically odd numbers are the left side of my head, or even numbers are the right side of my head. And smaller odd numbers mean it's closer to the center, big numbers mean farther. So CP3 would be about here, but the F5 would be about here, so more farther away from this midline. All right, so we have 8 channels. This is my device name. It's from Neurosity, it's Crown Model 3. And we have 256 samples per second. What that means is that if I was to just stream my raw brainwave activity, we would measure it 256 times per second, which basically means roughly every 4 milliseconds we would take a measurement of what's going on in my head. So we would miss events that happen even faster than that, but pretty much nothing happens even faster than that, because most of our brainwave activities are at maximum of 100 hertz. So maximum of 100 times per second sampling rate is actually enough to catch anything. So this is just to be safe, and we can pretty much catch any brain phenomenon at this speed. All right, now let's actually start to connect to it. So the way we connect this device is first we go into our phones because we can use a mobile app for controlling this device. I'm not sure how visible it is right now. In fact, let me join here with my phone to make it more visible. Can you hear my voice?
Yes. Yes.
All right, so let's get into it. So there is this app called Neurosity, and I connect to it. It looks like this. And here I see that it is my Neurosity Crown. It's currently not enabled. I'm going to turn it on by just double clicking on it. And I will connect to it now from Bluetooth. This might take a second. Meanwhile, let's see what this looks like. So basically, they have a way for you to meditate with it. It will keep adapting the music to your current focus and calmness level to keep you in the zone, pretty much. And also, you have some account informations and things. You can turn on some settings. You can also turn on haptics, and haptics basically means that you will feel a gentle touch on your head if you want. If you want the device to be able to talk to you as well, pretty much. And yeah, you can track your meditation or focus levels from here, but that's not what we want here. We just want to see the device itself. And yeah, basically we have device information here. Okay, it seems to be, let's see. One moment. Okay, we see now that it's connected. We see it right here. It's enabled and let's connect to Bluetooth. So pretty much it has to connect with Bluetooth to your device first, so that then it can connect to the internet. And here we can see that, yes, it's connected as well. And actually, now we can skip the phone phase because it seems we are already connected to my internet. So we would need the phone to first connect to the internet, but then later times we don't need it anymore. So okay, let's stop broadcasting now. Let's get back to our project now. All right. All right, so with that out of the way, let's share the screen again. Let me also turn on my camera. Yeah, so now our device is connected, as we can see right here. It's green and it's shown like this. Let's see what we already can tell about this device. So here we see all 8 of our channels. And if I put this device on my head, they will start to, make more sense visually. So let's see what that will look like. One moment. Looks like our meeting is about to end in 1 minute, and we'll rejoin after that, and we'll continue right from here. And we'll get into the coding of this. Okay. In fact, I'll end the meeting right here. So we have this device that's enabled now. We will see here my brainwave activity when I put it on, when I click start here. And some of the things we can do here, we can do some trainings. We can, there's some metrics here based on like when I had the device enabled and when I was experimenting with it. Here we'll also see how well I put this on my head. In fact, let's start doing that right now. So I'm going to put this on my head, like this, and then I'll start fixing it and just look at the signal quality. And basically, once they are generally mostly green, that means it's attached well enough that we can proceed. Okay, now it's good enough. You can see here, which means that my device is attached well, and we can start taking some measurements from it now. So first, simplest thing we can do is just look at my brainwave activity of each side. So you can see here what's going on. So each of these lines is the activity measurements at each of the channels. So there are 8 channels based on the places where we have those electrodes. And you can see here the reason why these are similar is they're either when I blink or when I swallow. I believe those affect all of them because those activities kind of get all over the place. But I mean, right now this looks very useless. We can't really get from this, oh, he must be calm or he must be thinking about this or that. But with some techniques we discussed before, we can actually start to make sense out of it. So I turned this off right now. And let's actually move into code now to see what we can do. So I have some coding examples prepared here. These code examples can be found at their GitHub. So GitHub is this nice website for those of you who don't know, where anyone can upload their code base and also documentation, which just means like a guide for how to use their code. And also anyone can contribute, which means that you can add to their code. And basically these Neurosity people have their entire project on GitHub. So you can take a look at examples of how you can use it in Python. It's called SDK, Software Development Kit, which is basically code that lets you use something. So for example, the Neurosity SDK is a code library, so a bunch of code you can use to talk to the Neurosity Crown. So in this case, this is the Python SDK. They also have a JavaScript SDK, but we don't really care about JavaScript right now. We just want Python since that's what we're learning mostly. I mean, not mostly, that's what we're learning here. So we go to Neurosity SDK Python on their Neurosity account. And here we see their documentation. They have some getting started, authentication, and so on. Let's just go through the basics. So we'll go through the first examples right here. Let's see what that looks like in our VS Code. So again, this is just normal Python code, but the only thing that's different is up here. So we haven't really done this before. I mean, the only thing we did was import math when we wanted like math.py or when we wanted math.square root of a number. And by the way, this is same as just 25 to the power of 0.5. But yeah, whatever. Point is, we can import libraries, which just means that just as we were creating some functions and code in our previous weeks, anyone could write some code, and in order to share that code with the world, they make that into a library that other people can import. And what that means is that, let's say, for example, I write some code that can, I don't know, let's say, detect Alzheimer in somebody's brain. I would make this into a library, and then other programmers can import this library and then call the detection logic in their place. So this is what libraries are. And for example, they have this Neurosity that we can actually install like this. I already have it installed, but if you didn't, you would just write pip install Neurosity. I mean, not from here. I mean, I would do it from here, but okay, let me just do it right now to demonstrate. So I would say pip install Neurosity. Pip. Okay, I'm making some kind of a mistake there, but I'll debug that in a moment and I'll tell you about it. But regardless, this code works. So let's just go with the code for now. We'll get into the setup in a bit. So what matters here? We have a Neurosity library, and it's just generally we say from Neurosity, we want some specific thing. And here we want the Neurosity SDK. SDK meaning software development kit. So the Neurosity SDK will have every piece of code that we need to talk to this device. So let's see what we do here. Let's go through this line by line, and we'll just discuss everything. So first of all, this line just imports the Neurosity SDK so that we can talk to the device. Then here we see from .env load import.load.env. So load.env is a function that will look for environment variables that we have, which set our email and our password and our device ID. So I have those right here. I'm not going to show it right now because it's not recommended to show your password to people, but generally it would look like this. So it would be like .env, and you would say like Neurosity email equals something at mygmail.com, then like password equals, let's say or something. That's not my real password, by the way, but yeah, I mean, you get the idea. So basically, when you want to have some username, password, and such things that you don't want to put directly into your code, especially because maybe your code goes to a public place like GitHub, but you don't want the password to go to a public place like GitHub, you create environment variables, which means just these variables live on your computer or on your laptop, and you just load them at runtime. So when you run your code, you'll see what's in under the name of Neurosity email, what's under Neurosity password and device ID. And then here's what we do. We say that so if you remember from before, in previous lectures, we discussed classes. Neurosity SDK is a class. It looks like this. By the way, I just clicked F12 to go to the definition. So this is what Neurosity SDK looks like. Yeah, let's not change things here. So it's a class. It has a constructor. It has some methods, like it has a method for logging in, for doing a bunch of things like acting on it, subscribing to it. You can see there's a bunch of actions we can take on it, such as calmness levels, focus levels, kinesis. We'll get into all of these. And basically, we'll be simply calling these functions. And these functions mostly call stream metric, which is this thing. And here's what it does. And it streams something from a pass, and here's what this does. Basically, it goes to the servers of Neurosity, which is sometimes it goes to the device itself, sometimes it goes to the USA where they have the server where they process information, and basically this code will just take information from there. So let's see what that looks like. So we initialize our Neurosity SDK by giving it the device ID. In my case, the device ID will be just right here. You can see this thing. So I have this string as Neurosity device ID. And here then I log in with my email and my password. I start to see some brain activity. So let's just run this code and see what happens. So you can see here, because I said right on this line, info equals neurosity.getInfo. And then I printed the info to the screen, and this JSON.dumps basically just made it look like JSON. So just made it look prettier, pretty much, so that we can understand what's going on in here. And so this is just the information about my device. So these are the 8 channels, or like 8 places on the surface of my head where we do the recordings, total of 8. This is my device ID. This is the name of my device. This is the address of my device and name and such, and sampling rate of 256, which again means that we take a measurement 256 times per second, or once every 4 milliseconds roughly. All right, this is one basic example of what we do, but obviously we haven't done anything yet. Let's get into more interesting examples now. So here's a little bit more interesting example. So right here again, we see we get the device ID from our computer environment variables. We get the email and password, and we log in. So this is just code that we had to put in so that we can just connect to the device. Then, for example, we can check what the status is just once, like status once is a function. You can see it's just a function defined on this Neurosity SDK class. And we call that function. And whatever result we get, we also print it to the screen. Let's see what that looks like. Here's what that looks like. It says right now we are at 33% battery. It's not charging, claimed by, this must be just some username. Last heartbeat was at this timestamp, or so like this point in time. I've been online since this point. Currently not in sleep mode. Currently connected to a Wi-Fi called ESA. Currently online, currently connected to Wi-Fi, and this is the strength of my Wi-Fi. So, for instance, we can see that, okay, actually I don't want to touch it right now because it's well attached, but if I were to plug it in, this charging would become true next time we measured it. Like if I take another measurement now, you can see the information is mostly same, but the last heartbeat changed because a little bit of time passed since then. All right, now let's get into more useful aspects of it. So let's say we want to just take a raw look at the brain without really understanding what's going on in there, just pretty much same as what we saw here. Like remember when we were looking at the activations here. So each of these was actually giving us, in fact, let me just turn it on so that it's clear what I'm saying. So each of these is actually saying, at this point you were this active, at this point you were this active. So it's just some number at a given point. And so for any given point, we can just take those numbers and see them on the screen. Let's do that right now, and then I'll get into the code of how we do that. So obviously we can't really make sense of this. Let me just turn it off. Let's take a look at what this means. So this is one recording, and here's what it looks like. So we have our data, which is in our 8 channels, I believe. So each of the channels got this and this and this and this. So these are just activity levels measured by each channel. These are the channel names for which we were measuring. 50 hertz frequency was used for notch. No, we don't need to get into what notch and other signal processing terms are right now. All right, one moment, I'll get the charger so that we don't disable. Okay. So let's actually fix the signal quality just because I moved a bit. Let's make sure that it's still at high quality. Maybe. Yeah, it looks good enough. Okay, that should be good enough. So basically, this is just raw data. It doesn't really make any sense from here, but if we were to write some code of like every time I think about, let's say every time I think about, I don't know, my friend, this is what my brain activity looks like these numbers. Then after like 1,000 examples, maybe an AI would be able to tell, oh, now I can predict when you're thinking about your friend because I can tell that that's roughly how it's supposed to look like. So that's the point of raw brainwave data. If you're not going to train some AI, then there's not much point in streaming that. But let's see how we did it just in case. So again, we imported the necessary code here. We loaded the environment variables, and then we connected to our device by specifying the device ID and email and password. And then here's what we did. We just said neurosity.brainwaves raw, and then we gave it a function of what function to call every time we get the new raw brainwaves. So this epoch is just a variable that includes everything we were printing on the screen a moment ago, which is just what activity each of them measured and what channels we're measuring. And so, yeah, pretty much that's what we did. So let's see what else is going on here. So we subscribe to this, which means that we listen for every time this device emits a signal. In this case, it emits a signal 256 times per second. And every time it emits that signal, we print it on the screen based on this function, because we say here print epoch. Maybe we could instead do something else with it, but for now, this is what we do with it. We keep the unsubscribe function here, which this actually gives us, so that when we want to disable our code, we'll call unsubscribe, and it knows to not send data anymore because nobody's listening. If we don't do this, then our device will keep sending data and it will basically run out of battery faster. So it's not a good practice, but it's not the end of the world either. And here we just make it sleep every 0.5 seconds, so that we don't actually print it to the screen too quickly. All right, this doesn't really matter. But yeah, this is roughly what's going on here. Now let's go into something actually practical. And actually, don't worry if you feel overwhelmed by this, because there's actually a bunch of new things here that we haven't discussed yet, such as imports and this try except block. It's not very important to get into the details right now, but roughly speaking, the purpose of try and except is that any code we write might crash. And crashing means that it encounters some error. For example, it tries to call a function on a variable that doesn't exist, or maybe it tries to divide by 0, or maybe we have a 5-element list and we try to take an 8th element out of it, but there's only 5 elements. So there are many ways in which our code might crash, and if we don't want our code to just crash and instead we want to be able to handle that and do something with that, we write try, we put our code inside there, and then when something happens, we can say except, and then the type of error that happened. So in this case, this is keyboard interrupt. Keyboard interrupt just means that I clicked on Control-C to turn off the code, which is how I stopped the code before. So like right now, if I click on this and run it, this will keep running. Then I say Control-C, and that's it, it will stop. So that's what keyboard interrupt is, and yeah, basically that's useful to stop. I hear how much data it already printed this quickly. But yeah. Anyway, now let's get back to what we wanted. So, what do we want? Now let's move to more practical use cases. So this raw brainwave data is only useful if you're going to train your own AI to recognize what certain brain activities mean. But let's see something that's already prepared for us to use. Focus and calmness metrics. So again, let's just break down what's going on in this 26 lines of code. First, we import the libraries that we need. Then we connect to our device at the given ID, email, and password. Then we define two functions. And by the way, every time you ask for something, which means subscribe to something, so tell me when you get a new measurement of focus or new measurement of calmness, you must define what you want to do with this new data. So we have functions for those. So this is my on focus function and my on calm function. So my on focus function will take this variable d that will have a probability, a metric, and a label and a timestamp. So for example, it will say probability of 0.5, metric of awareness, label of focus, timestamp, which is when I measured this. And here we'll print just how focused we are and how calm we are. Like we only get to probability, we don't care about the other ones. So actually this is a dictionary, if you recall, in Python. It's just also known as just Python object. They're roughly same. So this is just what it will look like, this D item. And now here what we do is we say neurosity.focus and we give it this on focus function. And we'll say neurosity.calm and we give it the on calm function. And we define these two unsubscribed variables so that we can turn off our connection to them from Python. And by the way, this is equivalent to this. But if we want to write multiple statements on one line in Python, you can separate them with a semicolon like this. Anyway, yeah, let's just keep it like this. Doesn't matter. What we do here is, again, that we pretty much just connect to our device. We ask it to tell us each time it takes a new measurement of my focus or calmness level, and then we print it to the screen. And 0.2f just means that print it all the way to last two digits. Like don't say I am 0.56238, so on. Just say only last two digits. That's what 0.2f means. Let's run this and see what happens. So right now it keeps predicting that I'm this amount of calm and this amount of focused over time. And it probably won't actually go to 100% at any point. I believe the device actually maximizes it around like 40 or 50% or something like that. But the more useful thing to do here will be to like just keep wearing it for about 5 minutes. See what your average readings of focus and calmness are. And then when you're working or reading or just doing anything, you would have this in you would be wearing this device. And for example, you would say, if my focus level drops below 0.2, warn me about it. In fact, let's do that right now. Instead of writing this to the screen, let's say that what I will instead do is here, let's say nothing at all, which is pass in our language. Okay, let's just say if probability is more than 0.5, let's say, then we'll say this is what your calmness looks like. And here we will say if my focus level, in fact, let's just define focus level is my probability. And if it goes below 0.2, just tell me, oh no, you are not focused at all. Or like in other case, maybe it will turn on music or block my Facebook so that I don't scroll or something like that. So actually, let's not do anything here. Let's just write pass because we don't care about calmness right now. Let's only focus on focus. Okay. So now every time it sees that my focus level is less than 0.2, it will say, oh no, you're not focused at all. So you can see it's more rare. Mostly I am focused. So let's see, else, just tell me you are focused. And in this case, we can see, let's see, I'm mostly focused, but let's see if I can get it to turn off. There, I got it to turn off for a second. Maybe it needs to be a bit higher. The barrier of being focused, maybe it's like 0.3, let's say. So now I'm focused, now I'm not. Now I'm focused, now I'm not. So I mean, right now I'm talking, so it makes sense that I'm not deeply focused on reading. Yeah. Yeah. So you can play around with this, like see what level makes more sense to you, or you can also train to recognize your specific focus even better. But generally, yeah, the purpose of this is that it can tell at each point if you're focused or not, and based on that, because we're connecting it to code, we could do some cool things like taking screenshots or taking actions. And I mean, in programming, we can take any action on a computer. So we can send a message, send an email, upload a video, maybe send a notification, block something, turn on music, anything. Or maybe even play a game based on this. Like if I'm focused enough, I will shoot a laser in some game or anything like that. So that's our focus and calmness levels and how they look like. In fact, let's just print the whole thing to the screen to see the entire focus stream of like what we are receiving. And this is what we are receiving. The label is focus, metric is awareness, probability of 0.17, and timestamp of this. So this is how likely it is that you are focused. You can see it keeps changing. Yeah, so basically we have focus and calmness given to us, but we can also create new metrics if we train for them. All right, and now the last, but in my opinion, the most fun aspect of what we can do with this device is kinesis. And roughly, this means detecting our motor commands. So just as before we were detecting how likely it is that I'm focused right now, now we will be checking how likely is it that I'm thinking of my left arm, or I'm thinking of my right thumb, or I'm thinking of my left foot, or that I'm thinking of jumping, or just any motion. But it's specifically for motions. It's not for words or visuals or anything. Because if you remember, the way our brain works is this area, the motor cortex, is responsible for motion, and that's where these are sitting, as you can notice. This area is for visualization. This area is for just conscious thinking and also morality and consciousness. This area is for hearing. This area is for sense of space and so on. And so right now we'll be focusing on our motor cortex to detect the intention to move, like I'm thinking of moving my hand, and then based on that, take some actions on our computer. So let's see what's going on the screen first. So again, we have our general library imports, and we connect to our Neurosity device as before. And here we say a kinesis label, just a variable, that we set equal to left arm. And now this is because, let's see where this comes from. In training, let me just create a new training. So we can train to be able to detect a specific motor command. So here's the options that we have. Artifact detector. Artifact just means like blinking or swallowing or just things that you don't want to be detected by the brain. But yeah, basically you need to detect it so that you can remove it from brain activity. We can also do all of these. Let's say for now, let's go with a simple example of left arm. Why not? So here's what's going to happen. Right here, I'm going to train it in front of you so that you can see what it looks like. It sometimes tells me to rest, and sometimes tells me to think about moving my left arm. Not to move it, but think about it. So I'm going to do that right now. And by the way, it's important to make sure that signal quality is good before you start doing this. Okay, you know what? This actually takes about 10 minutes, so I'm not going to do it right now. But basically, that's the idea that like it takes a bunch of examples of what your left arm movement, I mean, what your thoughts of moving your left arm look like. And then it has this idea trained. Uh, And now, because it's a little bit trained, it's not really well trained. It would not be very accurate right now. Let's ignore that for now. Basically, just as before we were telling it, hey, tell me when you think I'm moving my, before we were telling it, hey, tell me how focused or how calm I am right now. Now we will tell it, hey, how likely is it that I'm moving my left arm right now? So yeah, right here, everything is the same except now, so previously say we were neurosity.focus or neurosity.calm. Now we say neurosity.kinesis. We give it the label of the kinesis that we care about. In this case, that's left arm. And then we give it a function of like, what do you want to do when it detects it? And here what I want to do is we just print it to the screen, like what label we had, which is of course left arm, and what probability it is that that's what I was moving. So let's just run this right now. Let's see what its problem is. Okay. Quickly debug this. Let's just say print event. See what arrives. So this is what arrives. Let's disable this for a second so that we can make sense of it. So this thing arrives. Let's take a look at what this is. So it's confidence timestamp. It's confidence, label of left arm, metric of kinesis, and the prediction. Prediction being that I am moving my left arm with the probability of 99%. All right. So actually what this would look like is probability is probably more like events. Let's just directly go into that. So this is the object that we have. So we see here we have predictions. Let's say get predictions. And here, let's just print the predictions to the screen to see if we're getting it correctly. Basically, I'm trying to only get this data and not all the other stuff. And yeah, it looks like it's working. We're only getting this list now. Now, we don't actually need the whole list. It's giving us a list because it takes multiple measurements quickly. Let's just take the first of those. Let's not worry too much about all the others. So let's just say that our prediction is first element of the list, which is just like that. And what do we want in each of those predictions? We want pretty much just the probability. So let's now just say probability equals prediction and get probability. Then we will just print. This is the probability that I'm doing this. So let's see. It needs a moment to stabilize. But yeah, right now it thinks that it's certain that I'm moving my left arm. This is because I haven't trained it properly, so it's kind of a random noise, not very useful. You can see it kind of drop. But if I literally physically move my left arm, in theory it should go all the way up to 1 because, of course, I'm thinking about if I'm moving it. Right now it's a little bit inaccurate because we did not give it time to properly train, so the information currently is not very useful. But if we were to train it properly, even if I was paralyzed, I would still be able to just say, if I'm thinking of moving my left arm, let's say in my game move my character left, or maybe even I'm typing something on the screen and move the mouse to the left so that I can click on that thing. So the usefulness of this, I'm just going to disable it now. The usefulness of this is that you can map it such that you detect when you're moving your left arm or your right arm or your finger, or you're thinking of biting or just any movement. And then you can connect it to some code. So again, if there are some new pieces of code here, like libraries and this try except thing, and this subscribe, unsubscribe thing, but nothing crazy complicated. I will give all these coding samples. And generally, yeah, so the neuroscience that we've been discussing and the programming that we've been discussing can be connected to each other. And this is one way to connect it. It's not the only way, but it's one way. And so this way is basically we get a device that measures what's currently going on in the brain. And then we try to either make sense of it or connect it directly to, let's say, a communication or gaming, or even you can imagine, for example, if you have a smart house where, let's say, on a command you can open a window, you could say, if you detect that I'm thinking of biting a lemon, move a window. Or if you detect that I'm thinking of jumping, then open the curtains or close the door, or things like that. So the more things you can connect to the internet, the greater control you can get directly from your brain, so that you pretty much don't have to use a mouse or a keyboard, or even you don't have to speak. You can just telepathically do stuff, including communication, which means that, for example, you can chat with your friend telepathically eventually with this device. You would not hear it telepathically. You would still have to hear it from your earphones or headphones or whatever you have, but you can talk telepathically, which is pretty cool. So this is just the basics of what I wanted to show for today. This is our last lecture. And after this, we will have about 2-week period for final projects. And what we were thinking is that the final projects will basically be, roughly speaking, a presentation about one of the neurotech topics. So, for example, like find every piece of information you can about these EEGs and present, like, here's what they can do today, here's what they're expected to do in the future, here's how they can do it, here's what they cannot do, and to be prepared for us to ask you questions about it as well. That'll be one example. Another example would be to instead look up how MRI works and not EEG, or to instead look up how invasive ones like Neuralink or other brain chips work, and so on. So, like, that'll be one example of what you could be doing. So we will say more in the Discord chat about the final projects. But yeah, that's basically it for our lectures. And thanks everyone for attending. If you have any questions at all, feel free to ask them. And then that's it for our lecture.